Hello. Hello, everyone. Good afternoon. I would like to welcome you to this fourth webinar of the European Federation of Animal Science, which has been organized by the Study Commission on Precision Livestock Farming, and which is dedicated to the impact of PLF and sensors on phenotyping and welfare assessment. I am Francisco Maroto Molina, and I normally use my short name, which is Paco. I am working as an assistant professor at the School of Agricultural and Forestry Engineering of the University of Córdoba of southern Spain. I am one of the vice presidents of the PLF Study Commission that, as you can see in this slide, is composed of a large group of people who are enthusiastic of these topics. And we work together, coordinated by our president, Mati Pastel. I want to start with a few words about the main activities of the EAAP Study Commission on Precision Livestock Farming. As you may know, PLF has been an emerging area of great scientific and commercial interest for some years now. And there are a lot of developments coming up in these years. The PLF Study Commission within the EAAP has different objectives, and the following objectives are probably the most important ones. As you can see in the slide, first is to explore pathways to the exploitation of PLF research for the benefit of different agri-food chain users, starting with farmers, but also processors, retailers, consumers, etc. It's another objective to support the European PLF industry, which is one of the most advanced industries in this topic, and also to help to keep this level. To encourage scientifically excellent research studies addressing different challenges of animal production, such as more efficient animal production, the early prediction of health problems, animal welfare monitoring, etc., and all of these challenges across the full range of livestock species, including fish and grazing animals. And finally, to identify some contrast in relation to the application of PLF. For example, the differences between PLF solutions for very large farms or for smallholders, the consumer preferences, socioeconomic consideration, cultural differences, etc., in relation to PLF, and some other topics that are important for the study commission. Another important thing to highlight is that the activities of the PLF study commissions are focused on the relationship between the technology and the animal, and not so much on the technology gadgets themselves. Well, this year, as you know, we have the EAAP annual meeting in Davos, in Switzerland, from the end of August and the first days of September. And the PLF Study Commission has prepared several sessions, 9 sessions in this case, specifically dedicated to this topic. In addition, we will participate in another session together with the Genetics Commission in the topic, is precision livestock data really useful for animal breeding? I'm sure most of you will find this topic interesting. Regarding the PLF specific sections, we have several of them that are project sessions, meaning that they base on the results of different European projects working on different PLF approaches. And for example, we have session 74, where we will talk about the Zipele project that is dedicated to high performance computing and big data analytics for precision agriculture and also for precision livestock farming, specifically in pigs and fish. We also have another approaches, another projects working on different approaches. For example, cattle chain, which is working on traceability and welfare assessment tools for grazing animals, or for example, the session 77, which includes the projects Smart and Tech Care, which are dedicated to PLF systems for small ruminants, sheep and goats. So as you can see, we will have a very diverse sessions and complementary that hopefully you will find interesting, and hopefully we will see each other in person in Davos. Regarding the program of this webinar, this slide, you have the activities we are carrying out. After this brief presentation, we will start with Anna Stygar and Jarkko Niemi from the Luke Natural Resources Institute in Finland. They will present a talk entitled Sensors for Pigs and Dairy Cattle Assessment, Usefulness of Commercial Available Technologies and Consumer Perception. In this talk, they will present a systematic review of the technologies that are commercially available and externally validated in the fields of pig and dairy cow production. And they have carried out this review in the framework of the Clear Farm Age 2020 project. We will have 20 minutes for the presentation and 10 minutes for question and answers. And after that, we will go with Jarissa Maselyne, who will present a talk regarding recent advances in the field of meat producing livestock. She will present the results of the meat trial of another important European project in the topic of PLF, which is IOF 2020. Also, we will have some time for question and answers. And after Jarissa's talk, we will have 10 minutes for a coffee break, and we will come back to listen to Wijbrand Outweltjes, who will talk us about sensors, welfare assessments, and phenotyping in dairy cattle. And he will present some of their results obtained in Wageningen in the Netherlands. After this third presentation, we will have another 10 minutes for a final discussion and for closing the webinar. And hopefully we will finish before 4 p.m. Regarding the organizational issues, please remember that all the presentations and the video of this webinar will be further available on the EAAP website members restricted area. So if you are an individual member, you will have access to this information many times after the webinar. Please also remember that we will have 10 minutes for question and answers after each presentation. So please raise your questions in the chat box during or after the presentation, and we will translate them to the speakers. Another important issue is that please turn off your video and microphone during the webinar in order to avoid interferences. And Finally, just to highlight that we will have a rest during July and August, and we will come back with the next EAAP webinar in September. So stay tuned via the website and the social media accounts of the European Federation of Animal Science. Nothing else from my side. So if you agree, we can go with the first presentation of Anna Stygar and Jarkko Niemi. So please, when you want.
Yes, a minute, I will just share my screen. Can you see my screen?
Yes.
Yes. Not in presentation mode.
Okay. Now?
Oh, yes.
Okay.
Oh, yes.
Okay, so welcome everybody. My name is Anna, and together with my colleague Jarkko from Natural Resources Institute Finland, Luke, we will present today on behalf of the members of the Clear Farm project and our co-authors the selected results from the first year of the Clear Farm project. The plan for today is that at the beginning, I will very briefly introduce the Clear Farm project. Then I will present the results of the 2 literature reviews, which we have been conducted last year within the project on market availability of the sensors, their validation, and the usefulness for welfare assessment of pigs and dairy. After that, Jarkko will take floor and will present the results from the consumer questionnaires on precision livestock farming technologies. Let's start with the Clear Farm project. So the Clear Farm project is the EU-founded project, which aim is to develop the platform for animal welfare monitoring. This software platform will be based on algorithm processing data from available sensors and providing easy to understand welfare information for the whole value chain, so for farmers and consumers. To reach the project goal, it is evident that we actually need to have available, so widely marketed solutions that are also validated for the welfare assessment. Therefore, one of the first project goals was to conduct a wild market search on availability of different sensor technologies. This we have done using simply Google search engine and defining our search, which was systematic, using particular criteria that was based on different sensors types and problems related to health and welfare, both in dairy and pig industry. As you can imagine, we have spent some time doing this, but eventually we have ended with a quite extensive list of different technological solutions. So for dairy cattle, we have identified about 130 technologies with potential use for animal-based welfare assessment. They were from about 70 providers located in 21 countries. The top countries with providers for dairy cattle solutions were in the United Kingdom, the Netherlands, and the United States. Also, Germany was one of the leaders. Very similar approach we have used for the different marketed solutions in pig industry. Here we have ended up with 83 different technologies from 46 providers located in 17 countries. Very similar top countries as those offering technologies for pig production, the United States and the Netherlands, and also Germany was on the podium here. So now we know where we can buy different sensor technologies for animal-based welfare assessment. But what exactly we can buy? Well, it depends. For cattle industry, we have, well, both in the review for both industries, we have grouped technologies based on the sensor type used. In cattle industry, we have identified that accelerometers and load cells are the most widely marketed. Then, of course, very popular was also milk quality sensors. We have also identified some solutions based on boluses, cameras, and other sensors, for example, GPS. Regarding pig industry, we have seen slightly different pattern with load cells and flow meters and cameras basically taking more than 80% of the market. The remaining solutions were based on microphones, accelerometers, and some other types of the sensors. So we know where to buy, what to buy. Now it's another question, how actually these solutions are working. In order to find answer for this, we have turned into the published literature studies on this subject. So we have been looking on literature that was published in English in past 20 years. We have used a systematic approach based on PRISMA guidelines. We have defined our search very similar to the Google market search. So based on the sensor type and welfare or health problem, both in dairy and in pig industry. We have ended up with extensive literature library of about 2,500 different positions. In this, however, from this big set of the studies, we have selected only specific one, those that have been validated tools in external setting. So we have defined the external validation. That means that the tool, sensor, system or algorithm would have to be validated on different herds, also on different farm and different animals than used for system building. So in this example on this slide, if the sensor was validated on farm A and multiple times tested, but on the same farm was not qualified to our review, it would need to be tested on different environment externally, so on farm B. So using this criterion, we have limited our literature to only about 50 positions for both reviews. Now, having the data on market and on validation studies, we have merged this table to find the validation rate. So for the dairy cattle, we have found out that only 14% of sensors that are marketed have external validation records. The best validated sensors are those based on accelerometers. We have found out that about 30% of all sensors on the market that are currently marketed have some validation records. Some records were also found from cameras, load cells, milk sensors, but they were rare. For the pig industry, we have basically identified a literature gap. So only 5% of, or knowledge gap, maybe it's better say. So only 5% of currently marketed sensors for pig industry have any validation records. So now a few words how those tools were actually performing. If we have a validation studies, we should be able to say what is the performance of these tools. For the pig industry, it is very clear to say that pretty much we don't know based on the validation studies because there is such a low validation rate. For the dairy industry, actually, we know more And we have grouped those based on the performance, on precision and accuracy. The best performing tools were accelerometers for assessing non-active behavior, so lying and standing, rumination, and grazing time. Also, we have found that load cells assessing water and feed intake as well as body weight perform were classified as high-performing tools. The other sensor types were in a lower performance group. Even though the sensors have different performance records, they still can be used for welfare assessment, mostly due to the frequency of collecting the data. So finally, in our reviews, we were interested to combine our market search and validation search with the welfare assessment protocols. So in the reviews, we used welfare quality assessment protocols, which consist of 4 principles: good feeding, good health, appropriate behavior, and good housing. We have been trying to see how many tools on the market can be used to assess a given principle. For good feeding, we have actually quite a lot of available solutions on the market, both for dairy and for pig industry. To name few, this could be some solution based on the load cells. For good health assessment, we have actually plentiful of options, both for dairy and pig industry. Let's name a few, like milk quality sensors, accelerometers, or cameras, providing some alarms about the health of animals. Regarding good housing, also we have been able to identify few options. For example, video-based solutions monitoring the lying pattern of pigs for thermal comfort, or accelerometers monitoring lying time of dairy cows. What is evident is that actually currently we are missing the market solutions for appropriate behavior, both for dairy industry and for pigs. So there are we have missing solutions for expression of social behavior, good human-animal relationship, positive emotional state. Only exception here is expression of other behavior, where we have actually working accelerometer solutions that are marketed able to monitoring grazing time of dairy cattle. Now, what about the consumer's view on precision livestock farming? This will be presented by my colleague, Jarkko.
Okay, so I will share some results from a consumer research that we carried out within the Clear Farm project last year. And next, please. So what I will present is based on this part of presentation is based on altogether 6 focus group discussions that we carried out in 3 countries, and these were in Spain, the Netherlands, and Finland. So in each country, we carried out 1 focus group focusing on pigs and another focusing on dairy. And altogether, there were 56 consumers involved in these discussions, and the attendants were selected based on a few criteria. One of these was the innovativeness. So there was an innovativeness score, and then we were looking for persons who had this score beyond a certain threshold value. So in these discussions, we were trying to gain understanding of what consumers think about precision livestock farming and the use of sensors and PLF in dairy and pig value chains. And there were several topics that were covered by these discussions, and the topics that I will focus on are opportunities and constraints of PLF technologies based on consumer opinions, and then how PLF could transform the industry. So we analyzed these contents of the discussions, and next please. So one of the topics was that what are the consumers' perceptions, especially regarding benefits and risks that they associate with PLF. And as benefits, they identified, I mean, altogether, when taking all the discussions together, there were several benefits that they could see, and these included increased transparency in the value chains and the processes of livestock production. The consumers also considered that PLF offers benefits in terms of improving animal health and welfare. That was perhaps the biggest benefit that they identified. They also considered that there could be less emissions thanks to PLF because of more targeted and more careful production. Also improved productivity and control of production processes, possibilities for improving food safety, and even pain-free slaughtering were considered as benefits that could be associated with sensors and PLF. Finally, they also considered that PLF could provide more freedom to farmers because then there would be less dependency between farmers and animals in some sense. But the consumers also considered or identified several possible risks that could be identified with PLF. And these included especially increased digitalization and robotization of animal farming. And this was perhaps something that was quite important because at least some consumers considered that PLF could be some sort of some form of increased industrialization of livestock farming, and that was perceived quite negatively. Also, they considered that there might be decreased human attention to animals because of increased use of technology, and that might have negative implications on animal welfare. In addition, and especially in remote areas, people were a little bit worried about vulnerability of PLF technologies, and for instance, possible data leaks which could compromise data security and even personal data. And especially in remote areas, they were a little bit concerned about dependency on digital energy supply infrastructure and supply, which might cause problems to the farmer and to the animals. Other risks that were identified included lack of trust in the management of PLF data and more administrative work for stakeholders in the short term, especially to farmers. And finally, that there might be more technological waste because of the use of sensors. Next please. So what are then the big chances? Well, the consumers clearly identified several aspects which might provide a lot of opportunities for to transforming the livestock sector. And in particular, they found that detecting diseases earlier than with the conventional methods, that's a big advantage, and there's a huge potential for that when using sensors and applying PLF technologies in livestock sector. Also, forecasting and control of risk related to individual animals, that was seen as a benefit, and that would facilitate more individual care for the animals. And then informing consumers about animals' life, that was also seen as a big possibility. And in addition to that, best practices, enhancing excellence in practice, and changing nature of the farm work. For instance, when farmer is moving to use PLF technology, then the nature of the whole work is changing, and it might be more monitoring and treating like the sick animals, and therefore being able to provide better care for the animals. And with regards to the actual production processes and stages of farm animals, the consumers expected that PLF would affect current practices once the technologies have been integrated in the value chains. And especially in the reproduction stage, the consumers express the expectation that PLF and the associated technologies would foster genetic control in order to improve breeding practices. And this could result in healthier and better performing animals. So this linked to the first point on the slide. And then regarding stress, and quite interestingly, although the participants of the focus groups expected that the integration of PLF technologies would reduce stress of animals in the pig production. By contrast, they expected that it would increase the stress in dairy cows, and therefore the cow's life would be more data-driven, and this could reduce interaction between farmers and the cows. So in that sense, the results were a little bit conflicting. Well, in addition to what has been presented here, the Clear Farm project has also looked at consumers and farmers' views towards the organizational platform that is being developed in the project. And this has been done in 2 other surveys that we are not presenting here. But in those surveys, in general, consumers like the introduced Clear Farm app and platform, and the attributes that were considered in that study. And that they considered that they could actually utilize data originating from sensors in their shopping decisions and shopping trips. So in that sense, sensors can provide information that is useful to the consumers. And also the farmers considered that there are a lot of possible benefits in using sensors. But for farmers, it was really important the organization that manages and coordinates the information collected by sensors. So, so in that sense, also from the farmer's perspective, for instance, the possibility to influence the data and data security were considered quite important, as they were considered by consumers as well. So next, please. So let's draw a few final conclusions. So we have four conclusions. The first one is that to increase actors' trust towards PLF technology and prompt sensor-based welfare assessments, more validation studies are needed. And then secondly, sensor technologies, also those with lower performance, they can provide useful information on animal health and well-being. And thirdly, integration of PLF technologies in current protocols for animal welfare assessment would make them more robust. And in that sense, the system should operate as a whole. And then regarding the consumers see that there are benefits of PLF in terms of improved animal welfare, health and production control, but they are also a little bit concerned about vulnerability of the increased technology dependence, and also about the risks of robotization in the livestock sector. So those are our conclusions. And finally, I would like to mention that what we presented here are based on 2 systematic reviews that you can see on the screen, as well as on a consumer study. And these have been published in 3 different articles that you can see here. And this all was done in collaboration with a number of co-authors from the Clear Farm project, as you can see in the screen. So with that, I would like to thank you for your attention.
Okay, thank you very much, Jarkko and Anna. We have no questions from the public by now, but you can ask later at the end of the webinar. But we have a question from another speaker from Wijbrand, from the Wageningen, and he said that regarding the validation of milk sensors, do you refer to the quality aspects or also to the quantity aspect of milk sensing? I don't know if Anna or Jarkko can answer this question.
Yes, I can try to answer. Quality and the quantity. So I think that as far as I remember in the review, we had actually both. So we have identified exactly what kind of parameters were validated by particular groups, and they were of course some studies that were validating several parameters for different quality aspects of the milk measure, but I recall at least somatic cell count. That was one of the validation study with which we have been able to identify, but the quantity of milk, that is difficult, a little bit tricky question, because I cannot recall immediately. I would need to check the big table that we found, but I can add here that actually there was less validation studies for milk quality sensors, and I believe it is also coming because some of the validation studies are a little bit hidden by the ICAR ISO standards, that this is some of the milk quantity sensors have to have ISO standards, and those validation studies were not included in our reviews because they are basically done by the ICAR when those sensors are actually assessed for milk quality monitoring and quantity.
Okay, yeah, thank you. That was really the background of my question, because I thought that milk meters quite often would be used, say, for official purposes and then would be validated. But okay, now I know how you went through this. Okay, thank you.
Okay, thank you, Anna. We have other questions from Celine Talet. Do you have an idea why there are less sensors developed for pigs than for cattle?
Developed, well, I would say maybe because again of the group aspect, that the pigs are monitored at the group level and the dairy cattle is monitored at the individual level. That would be my first idea. Then well, maybe also what we want to monitor from these two groups of animals. In dairy production, we have lots related to milk quantity and quality, so there is some aspect extra on the production level. Regarding pigs, we have, for example, body weight monitoring, which is both for health and for production. So maybe that explains why there is less sensors developed. Well, that's also not explaining why there is less sensor validated. There should be more, but yeah, another question that potentially is.
Thank you. And also from Celine, how do you see the role of the farmer if automatic systems develop to monitor welfare and health of their animals? It's a more general question.
I guess to just react as fast as possible for any problems. This is the main point, that there should be the reaction and there should be something done if the health and the welfare is deteriorating. So we see it as the kind of another monitoring aspect. And also the obvious thing is that there will be the potentially higher price for the products produced in the better quality. So farmers could sell it with the better price. So if they can also prove that the production quality is good, then maybe there also the option to sell it in the better price.
Thank you very much. More questions coming up from Alan McElliott. Anna, very nice talk. There seems to be a PLF review published almost every week. It's difficult to keep up. What advice could you offer to where to even start deciding about what tech to choose for a farm or a research project?
I didn't get that, but I cannot see
what advice would you offer to a farmer or to a researcher that need to start? There are a lot of different technologies. How to choose?
Extremely difficult question. I would say it's well, maybe I would refer to some kind of farm advisor, because it absolutely depends on the production type, on the number of animals. absolutely tremendously difficult question to actually answer. We in the reviews we've been checking pretty much how the tools are working. It seems that they work. Some of the tools are actually working very well. Some of the tools work in acceptable level. So it's basically also a helping tool for the farmer to find those animals with the problems earlier. So I would say especially important for the herds with the bigger number of animals, to try to look for the technologies can help detect issues earlier.
Yeah, very, very difficult question. I used to tell my students that the best answer is it depends. So
it depends, exactly.
Another question, and we are trying to finish to continue with the next talk. This time, do you find or recognize any technology that can assure consumers that an animal life was lived without stress in order to defend animal production from PETA and other animal organizations?
There is no single technology like that. There has to be the combination of these technologies by now, and basically in the Clear Farm project we try to pilot something like this, that we use a combination of technologies to be able to say about animal welfare. But based on our review, we already see that we will have a problem based on appropriate behavior of animals. So we would not know exactly using the technologies on that, but potentially there are also other options used, like frequent controls on the farm to check this aspect.
And just a last question for Jarkko. Do you think that consumers fully understand what PLF entails? And can they really give informed answers for an attitude survey?
So in our focus groups, we actually provided them an intuitive or quite a simplified explanation what PLF and well, actually not what PLF is, but what the production process is. And in my opinion, yes and no. So consumers can evaluate things when they have a certain type of descriptions available. But then what it actually means, what PLF actually means, and what is a production process like, for that many of them have quite limited information. So yes and no. And maybe to also to respond to or to complement the previous question, what seemed to be quite convincing from the consumer's perspective was that if they see, for instance, video or there's a possibility of like a live picture, that was something that was considered as a convincing, but perhaps that is not so relevant in this respect, that it would actually be PLF technology. So what is actually important for the consumers is also that there is somebody who is a reliable, independent body that is making sure that the information is trusted.
Okay, thank you very much, Anna and Jarkko. We will continue with the next talk in order to fit to the timetable. So the next one is Jarissa Maselyne. When you want, Jarissa.
Okay, thank you, Paco. I'll just share my presentation. So we should be able to see my first slide now.
Yeah.
Yes.
Okay. Then I'll get started. So my talk is about some recent advances in PLF for practical use in meat-producing livestock, which is basically the results of the meat trial of the IOF 2020 project. So my name is Jarissa Maselyne, and I work at ILVO, which is the Flanders Research Institute for Agriculture, Fisheries and Food in Belgium. And I'll lead you through a short overview of the entire project that has finished some months ago. Then I'll give an overview of the meat trial results. So I'll cover 6 different use cases. and conclude with some take-home messages. So the goals of the IOF 2020 project. So IOF 2020 stands for Internet of Food and Farm, and it started in 2017, and as I said, it ended in March 2021. And what we worked on was, first of all, it was a large-scale pilot in the Horizon 2020 program. So we focused on large-scale uptake of IoT, specifically with 33 use cases in 5 domains. A lot of focus was also on the IoT business cases. So those 33 use cases worked in total on around about 58 prototype products, which ended at the end of the project on TRL levels varying from 6 to 9. So also several products are actually already on the market. A big issue was, of course, also technology integration. So since it's about IoT, since it's about the connecting network of sensors and devices that work together to collect information and even do autonomous actions in some cases. We were talking about a large number of types of devices, so over 200. And then, for example, in the meat trial alone, over 2,000 units were used, which included tags and transponders on the animals. User acceptability was a third and very important pillar. We did these tests and developments were happening on farms, so 223 farms. A lot of them practical farms, some research farms, also some other deployment sites where you have, like for example, milk processing plants or slaughterhouses. And also to demonstrate the solutions developed, there were a lot of events organized, a lot of virtual events, of course, in these days, but still demonstrations nonetheless. And then the last part that I want to mention, what we had is also a very big ecosystem. So it was really a community. It was a large project, over 100 partners and a lot of other stakeholders involved. So it was a very big project, which had, of course, its own challenges, but it was a really interesting journey that we went through with lots of results. So if you look at where our deployment sites are, so where are those farms? They were across the whole of Europe and covering 5 trials, so arable, fruits, dairy, vegetables, and meat. I'll only talk about meat use cases now. And for the rest, of course, you can find more information on the website, for example. So these use cases, they were each a smaller group of a multidisciplinary team. So at each time included end users, infrastructure providers, IoT companies, and researchers. And we followed as much as possible in the use cases a lean development approach. So where the focus was on, rather than for a length of 4 years developing a product and only then bringing it to an end user, was to go in short iteration cycles, develop a minimum viable product, and directly deploy it and install it on the farm and have it tested by the end user, so that we could directly receive feedback, but also see where the technology is going wrong, where are there still bugs in the system, which things need to be improved. And in the meantime, also see what is the impact on the farm itself, and can we measure some key performance indicators and do a business evaluation on that. And each time with that feedback, develop a new iteration of the product, a new minimum viable product, and deploy it again. And this way, have a really lean development cycle. So the meat trial consisted of 6 use cases. Due to time, I'll of course cannot go into details of all 6, so I'll just mention really the highlights of the results and what they worked on. I was myself involved in the pig farm management use case, and the rest I followed more from the project level and from the trial level. So you see, we have use cases on pigs, we have on broilers, and we have them on beef cattle. So first of all, the pig farm management use case. The goal there was to provide a pig farmer with tools and especially also the information to steer his farm management. So pig farmer has already a lot of systems running on his farm just for feeding and for ventilation, for example, that actually generate data, but that is not used or not coupled together. And he cannot really see any information. He can maybe export the data, but still with these very large data files or Excel files, I mean, he cannot do anything with it. So it's important to bring this information together of what is already there on the farm, but also what is coming from the slaughterhouse, for example, and potentially also add other sensors to that. So here you see a drawing that was made during the project of the main goals and products of the use case. So the main vision is to create a big business intelligence dashboard. Now, I don't know if you see my pointer. That makes it easier to follow.
Yes, we can see.
Okay, great. So as I mentioned, you already have things like the temperature, water, mortality rates, even feed and weights of the pigs collected on farm. And the idea is to collect all of that and add this in a intelligence dashboard, also with some things like reminders on actions to take, comparisons possible between compartments, between rounds, and historical reporting. And that has all of this information is visible in one place, together with also information from, for example, the veterinarians, or he can consult this information from the slaughterhouse, from suppliers and advisors, so that everything is centrally organized, and also valuable insights are gained to it. So also warning systems and predictions are added to it. So that is the main idea. And that is also the first outcome, is actually linking all of this technically together. So the data from the farms, system independent. So we worked with several Dutch pig farmers that already had systems installed. So we had to work with systems from different suppliers that were maybe not yet ready for this data connection. So there was some work needed on that level. To collect this in real time and really at the lowest level that they are available. So at compartment or pen level, and for example, every 15 minutes, depending on the variable. So for climate, feed, water, weight, and added the slaughterhouse results, and put this all together in a dashboard. Now we actually did this methodology on 3 levels. So on the farm level, or actually the group level within the farm, the pen and the compartment. We did it also for the slaughterhouse data in a batch level. And we also worked on really individual data per pig collected with RFID-based sensor systems. Due to time restrictions within the project, we did not manage to couple all those levels together, but that would be a next step, or end goal is to really connect all 3 of these levels and have them available. So now at this moment, it's still 3 different systems, so to say. So the outcome of the project was then the dashboard, combining the data either on compartments, pen or pig level, related early warning systems and predictive algorithms. And we also did work on slaughterhouse reporting on short and long term. There are already companies out there in the market that offer this, but still there is more information to gain from it. We learned, we did this with the farmers, and we had them we went through some iterations with them and found out that there is still more information that is useful to be found. And also if the pig farmers keep track of it, you can even couple it back to the compartment and level and pen level, and really find differences between compartments, for example, and detect in that way that something is wrong in a certain compartment via the slaughterhouse results. So that was our first use case. The second one is the poultry chain management, where the goal was to optimize both the production, transport, and processing of poultry. So they also worked on 3 levels, which was the farm, the transport, and the whole chain level. And again, a set of partners contributed to this. And here we see it's a similar goal, similar approach you will see, but different accents that are put there. So here we're talking about also about collecting data that is available on the farm, but also novel sensors. I'll show them later on for environmental monitoring and weight monitoring. Also, a trial was done with monitoring the movements during loading of the chickens via smartwatches. Environmental sensors were added in transport, and all of this data was via fireware-based data platform. It was collected and then also put together in a dashboard for a poultry farmer, but it also is very relevant for an integrator. So it was tested in Spain, where they can see insights of the whole chain actually. So the outcome was on different levels. So if we see the novel sensors, you see here on the bottom the environmental sensor that is used in a farm or a similar device on transport. This is an example of the smart watches that were used. This needs further development though. And this is a dynamic poultry scale that was put on the market by Exafon, and that monitors the weight. And then on the side of the dashboards, we had a smart farm assistant that was developed, an environmental monitor, including predictive models. So to predict upfront when there is going to be a problem with the environment inside the barn, for example, and that chain level management decision support tool. And then the third use case was on meat transparency and traceability. So the goal was clear. This was to have transparency and traceability in the pork chain. But the first steps within the use case were to actually find a business case that could be applied to it. I mean, we can all understand that transparency and traceability is important, but still there needs to be an incentive to start with it. There needs to be a clear business case and a clear added value for it. So that was found in a way with a cooperative that did so that does certification and related also auditing of a large number of pig farms in the Netherlands. So this chain is actually focusing already on RFID registered animals. But what they did before IUF 2020 was to have on-farm visits and collect data for the auditing. Now, with the use case, it has been realized that a lot of this data is collected in real time and via an automated digital manner. So that also from already the food supplier, information about the feed is collected from the farm. A lot of information is collected, but also from the veterinarians and from the slaughterhouse. And this is all combined in a dashboard for real-time auditing. So this helps the farmer with real-time info and showing that he is certified and meeting the goals. It helps also the auditor, again, with real-time info and with cost savings, and the consumer with a guaranteed transparency of the whole system. So the outcome was, of course, this proactive auditing tool that resulted in a 30% reduction of time and costs spent on these manual inspections. And this use case also worked on the combination for people that are a bit more technical in the audience, combination between two commonly used standards. So you saw already that our two previous use cases used fireware, specifically the Orion Context Broker, which is an entity-based database or standard, and the GS1 EPCIS standard, which is an event-based model. So these are completely complementary, and a mediation gateway was built to exchange data between the two standards. The fourth use case then is on beef, is on decision-making optimization in the beef supply chain. And they had a lot of deployment sites, as you can see here on the map, and for both beef and sheep farms, and also a couple of horses here. And they worked on a lot of different products and developments. Together with, again, you see a lot of the goals are matching with, for example, the first three use cases, but the accents are different. So here we're talking about, on the one hand, extensive livestock that are being tracked with GPS collars, but also the calf is being connected to its mother with a Bluetooth ear tag. so that we see the interactions and the duration of those interactions. And then in the feedlots, IoT scales are used up till the consumer that can actually, through a QR code, scan the meat and see where the animals are coming from, where they have roamed, so on which grasslands, how long the calf was with the mother, and so on. And this is all connected through a blockchain infrastructure. So if we look at the outcome, there are a lot of different products developed here. So you see here the GPS collars for the cows that also include a lot of alerts for the farmer. You see here the IoT weighing scale in the feedlot, where the cows can go in and the calves can go in when they are drinking, and they are automatically weighed and identified. And that resulted, on the one hand, for a dashboard for the farmer, so he can see all of this information. He can get the alerts. He can track his livestock, see where they are, and directly navigate to them. And on the other hand, also this QR code on the meat, where the consumer can scan it and see the location of the pastures of this farmer, but also where the specific cow has roamed, and any other information for transparency purposes. So then we come to our last two use cases. This one is on the feed supply chain management. So it actually has as an end user both the farmer and the feed supplier, because it benefits, this product benefits the both. So the goal was to optimize the feed supply chain and logistics through silo stock monitoring. So here you see the content of a silo. Usually it's checked visually. You see here that there is a gap to see how much it is filled, but you see that it can also be quite deceiving, but because it looks like it's filled, while on the inside you see that there's a big hole created. So there's a lot less feed than you would be expecting, for example. So the goal is to collect accurate silo data, and this has been done through a solar-powered plug-and-play camera system that monitors the silo continuously. It does not depend on any mobile phone networks, so the data goes to the cloud, and then the solution is actually that there's not only the volume measurements and then the real-time information, but also forecasting and status alerts, so that the farmer knows when the silo is almost empty, which saves the costs and errors if silo is empty before the feed was actually the new feed was delivered. But it also serves for the feed suppliers for real logistic and planning. If they know upfront which silos will need refilling, they can really plan their logistics in a much better way. So this is the camera, and that is, of course, the main product that comes out of this use case. But also there was work done on the business models, both for the farmer and the feed supplier. And it was clear that there was a working time and cost saving, both on the level of the farmer and especially on the feed supplier. So it was clear already that that transport costs could be reduced heavily, and also errors would be saved a lot with this product. So it was tested also across Europe, specifically in Spain and in Sweden and in the UK. So since it's solar powered, it's now also adapted more to the north of Europe. Some work needs to be done on that, and work has been done on the technical level, also on accuracy and stability of the device. And then last but not least, our sixth use case is about big health tracking, with the goal of improving animal welfare and sustainability of livestock production by monitoring physiological parameters through IoT sensors. So this is quite a novel system, where we have on the one hand we have air quality monitoring And on the other hand, we have the monitoring of the heart rate of the pigs with an ear sensor that is then collected also through a smart spot device on the cloud and visualized. So with recording of events, with an app for farmers and veterinarians and an alert system. So it focuses on heart rate, which is helpful for example, farrowing monitoring, and on the environmental conditions in the barn. So specifically the outcome you see here on the right, the sow with the ear tag in her ear, and you see here an example of the data that comes out of it. So the heart rate ear tag was developed and tested in Sweden mainly, and it includes also an accelerometer inside. So there was work done on, of course, the mechanical construction of everything and making it pig-proof. And the results of the heart rate measurements show indications of promises for farrowing detection, for estrus detection, but also for fever detection and general health monitoring, also in combination with the accelerometer. Next to that, we have the environmental monitoring device that was developed and validated, and the, of course, app that brings that information together that is available for farmers. So that was a broad overview of the 6 use cases and shows you some of the recent developments and products that are being developed. It was each time, I think take-home messages is that each time the use case was really a multidisciplinary team that worked on these iterative development cycles, and that is really something that is key for a successful development. To have these influences from different or the knowledge of different people combined, different teams, and this quick and lean development cycle, so that it was immediately clear when you develop a minimum viable product and you go and test it immediately on a real farm, then the problems become clear very quickly. And rather than going on for years and years to develop a product and only then going for real life testing, then you will reach into problems. Well, now you can tackle the problems very early on, and also with smaller batches. So for example, if you have an electronic component that is faulty, you will detect it a lot earlier before you are ordering hundreds of sensors and then realize that there is something wrong. It can always happen later on as well, of course, but still a lot of the big problems can be filtered out in an early stage. So you see a lot of diverse IT solutions and products, a lot for similar purposes, but still with a lot of different methodologies and different takes on the challenge. So the meat trial had in total 66 installation sites in 10 countries. So it was widely tested across Europe. And challenges did arise. So I'll show you now the final outcomes, but we had a lot of challenges, of course, that needed to be overcome. Technically sometimes, but also very practical challenges and on the business side, but they can be overcome with the right work and with this iterative development cycle. And finally, the feedback of the end users really proved crucial for steering the right developments. So it was really only by connecting with those farmers, for example, that the companies understood what is exactly the needs of the farmers. What do they need from the product? How will they use it? And sometimes even also that the farmers themselves only realized how they can really use it after they have been able to test it the first time. That they see, oh, it has also these possibilities. Oh, could you not add this? I think that would also be interesting. It's only when you have something concrete in your hands that you can really give the right feedback. So that was my presentation. Thanks a lot for your attention, and you can always contact me for further information or the use case teams directly.
Thank you very much, Jarissa. We have a couple of questions. The first one I think is already answered, is do you have experiences with fish there is no fish use case in iOS 2020. If you
Nope.
want to add something, or do you know about other projects working on fish?
Yeah, I think, like you mentioned in the introduction, if you come to EAAP in Davos, then you will hear some fish results as well from the CBEL project, for example. Yeah.
Okay. And there's another question: is how did you prevent pigs from not munching other pigs' heart rate ear tags?
Yeah, that is indeed a challenge. That was actually the biggest challenge in that use case, is how to make the sensors pig-proof. So it had to be really robust, but because it contains a small battery, which also could have some potential hazards. So it really was made very strong, this first prototype, and it was used, as you saw, in the farrowing crate. So it was only the smaller piglets that could bite it, but still it was made actually resistant to a pig bite. But this creates a very expensive sensor. So for later use, they should think about making it cheaper and still safe for use in the barn. Yeah.
Okay, another question arose. Very good and great job, Jarissa. Can you tell me when integrating data from multiple sensors, each data format may be different? How do you solve such a problem?
Yeah, that's indeed a challenge that probably each of the use cases needed to deal with. By collecting the data through a standardized data model was usually made as one of the first steps in the use case to see, for example, if you use the Fireware Rhine context broker, it's entity based. So you make entities like pigs and pens and compartments, and you then adhere variables to it. And then if you need data aggregation of different timestamps, of course, you need to match everything together in some way and link it and then do an aggregation or a visualization based on that. So it's something that you need to work on case per case. But there are systems available, there are data standards available, standard data models as well that can help you get started to do this. Yeah.
Okay, thank you. We have no more questions by the moment, but we will have another opportunity at the end of the webinar. So in order to fit to the timetable, we are stopping here. We will have 10 minutes for a coffee break. So we will meet again at 3:20, 3:22. Thank you very much to everyone. Well, welcome back after this short break. We are going to continue with the program. So now is time for our third presentation, which will be presented by Wijbrand Outweltjes. Sorry if I don't pronounce very well your name. So Wijbrand, when you want. Wijbrand? Maybe he's still on the break.
Still on coffee break mode.
Yeah. Wijbrand?
Yeah, no, I'm not on a coffee break, but yeah, my screen went too small, and now
okay.
It's okay again. So
okay, you
I
can
will start the presentation. Oh, wait. Let's get rid of this one. Okay, you should all see my screen by now.
Yes, we can see.
Okay. Well, I will have a presentation about sensors, welfare assessments, and phenotyping in dairy cattle. This title was given me when via I was asked to contribute to this meeting. And indeed, Francisco, my name is spelled a little bit differently than it was on your slide, but that doesn't really matter. I work for Wageningen Livestock Research in Wageningen. Oh, sorry. Why? Yeah. Okay, a little bit about myself. Well, my name I already gave. I here show the front of my thesis, but it's on the effects of mechanical loads on the deformation and health status of claws in dairy cows. This thesis I defended 3 years ago, so quite recently. And it helped me to understand like the value of using cameras for obtaining data, because cameras in this research were used like as a very accurate measurement instrument to monitor positions of the phalange of cows when they are loaded. Some of my research topics, well, it's mainly all about dairy farming. The main red line is health and welfare. I work in the Department of Health and Welfare of Livestock Research. There's a strong link with housing related to health and welfare. Claw health is one of the focal areas. Perinatal death, we recently did a desk study for our ministry on perinatal death of calves, piglets, and young goats. Because there were some questions raised by our parliament on this matter. My background is in animal breeding. I graduated in animal breeding from Wageningen University in 1988, so a long time ago. I also did some work on animal transport in relation to welfare aspects, and I work on monitoring animals, and then mainly on health and welfare monitoring. There are quite a number of projects I am involved in, but with many other people also in our institute, but in some cases also from abroad. Breed for Food, it's a Dutch project with industry partners on, well, some, it's all about breeding and then over species, usually some, well, the novel traits that are of interest and novel technologies for data collection. I participate in the Free Walk project, which is an EU project on housing of dairy cows. I also participate in the Gentle project, which is a big EU project on tools for phenotyping in cattle. And there is another project which is just starting up. It's an internal project at Wageningen. It's called NLAS, which stands for Next Level Animal Sciences, where we are going to, well, we hope to be better prepared for the future by doing this project. And that project is together with Noldus, probably known by many of you, company in Wageningen, well, providing tools for research in animal health, behavior and animal welfare. We do a lot of our work on our research when it's in dairy cattle, a lot of our work on our research facility, Dairy Campus. It's in Leeuwarden in the Netherlands. It has about 500 cows. For research, it has some specific equipment, like there's a unit where they can measure the feed intake of the animals. There are mainly management sensors which are used for the daily farm management, which are a location system to track the cows from NADAP, which is mainly used for the day-to-day farm management and not very much for research. The cows also do have neck tags from NADAP to alert for heats and so on. There is a unit from the Laval at the exit of the milking parlor where body condition scores are monitored when the cows pass by. They're also passing on a weighing scale after every milking. And of course, there's quite a lot of information collected in the parlor, in our case from GEA. I thought it was also important to say a few words about terminology. When I was given the topic phenotyping and animal welfare, I immediately thought, well, some people means very similar things, but use different words for it. And that comes, well, in relation to precision farming, where animal breeders talk about phenotypes and genotypes as two important things. when we talk about sensors, we often speak about features and algorithms. And when I talk to my colleagues in our department who are more into welfare assessment, they talk about resource-based measures to measure animal welfare and animal-based measures to measure animal welfare. And well, particularly if I compare animal-based measures and phenotypes as well, terminology used by breeders, there's a lot of overlap between those two. Another thing, when what I considered when I was asked to say something about phenotyping, is because nowadays we are more and more interested in complex traits that cannot simply be measured by one parameter. So there are often multiple readouts for something that we want to know more of. Examples are health. You cannot measure just one parameter to say everything about health. The same is with welfare. The same is when you're talking about efficiency of an animal, resilience of an animal, or locomotion. And well, for those complex traits, more and more, if we can, we use sensors to collect time series data. So a lot of data with a lot of measurements throughout time. Why do we want to do all this? Why do we do welfare assessments? Well, they're usually done at herd level, not at an individual level. And we use, well, the so-called animal-based and resource-based measures. And that is because, well, the animal is telling how well it is, but there are also some constraints in their surrounding that are also determining how well they are, or how well they are expected to be the next day, for instance, such as the amount of space they do have, or do they have or do they not have, say, the ability to graze, that sort of things. Why are people interested in welfare assessment? It's often applied in quality assurance schemes, like our dairy companies nowadays, about every 3 months, want to have the welfare of our dairy farms assessed to monitor and to be able to guarantee to their customers that welfare is being monitored on the farms they get their milk supplied from. But because, well, this way of working, and also because it's very time consuming, welfare assessments are usually done infrequently. Every three months is at maximum at the moment. One assessment, if you do it completely according to the welfare quality protocol, it is costing about 1 day for one person. So that's much too expensive to do it more regularly. If you do phenotyping, like the animal breeders want, then you're particularly interested in data per individual, and they can be used as an input for breeding. And that's mainly where the animal breeders are interested in. But it can also be used for farm management. But then it depends how often you can measure it, how you can apply it in the day-to-day farm management. If it's for breeding, it's required that traits are measured on many farms and for many animals, and preferably also quite frequent. And it, of course, depends a little bit on the trait, whether it makes sense or not to measure it from day to day or even more often within a day. So what are some important differences between phenotyping and welfare assessment? Well, one of them is a reason why are you doing it? Are you doing phenotyping or welfare assessment for a research purpose or for a farm management purpose? And welfare assessments are also often done mainly for research purposes. And those have other requirements than when it's done for farm management. Phenotypes can be interesting for breeding, but maybe irrelevant for welfare. I'm not sure if it's true, but I think that like the methane emission level of an individual cow, it's probably not directly linked to welfare, but it is directly linked to the environmental footprint of dairy farming, so therefore it's interesting for breeding, particularly nowadays. There also might be phenotypes that are important for welfare, but if they are not heritable or if they have very little genetic variation, they can be not of much interest for breeding purposes. I will go through this very quickly because I think there's already a lot said about sensors that can be used. There are sensors that, well, and of course, if you use sensors, you get a lot of raw data. So then you also need big data technologies to get out the information that's in there. Well, the kinds of sensors that we are working with or going to work with is image processing, animal tracking, accelerometry, and other sensors like sound, temperature. Well, and I also consider milk yield, body weight, body condition score as a kind of sensor, although like body condition scores can be in the end based on image processing. Some other terminologies that are linked to sensor data are machine learning and pattern detection. It is a booming area of research, but it's still, to my opinion, still in its infancy. I think there are a lot of promises that are can be achieved, but they still need some work done before we can get out of it what is potentially possible. Well, assessing welfare, I am quite familiar with the welfare quality protocol for cattle. Most of it is based on visual assessments, particularly the animal-based parameters. So it's very time-consuming to record the information and therefore not suited for frequent or large-scale application. And that can be a problem, well, to apply it in practice, but it is also particularly a problem when it's applied or when you want to apply it in a research setting. And therefore, we are now going to work on a better toolbox for welfare assessments. Well, as I said, the traditional approach is visual observation of behavior and health. And the main focus, usually also in farm management, is on the absence of abnormalities. And there is not much focus on the presence of, say, positive signals. We combine our animal-based observations with resource-based measurements. And but there are possibilities for automation. If I look at the animal-based measures that are in the welfare quality protocol, in, for instance, the principle good feeding, well, body condition score, there already is an apparatus of the Laval, which can automatically record body condition scores. But I think it's probably not too well validated, and it's at our research farm, it's not really used intensively at the moment. For good housing, there are also parameters that are inside of the welfare quality protocol that can be automated, such as the time needed to lay down, laying partly or out, laying completely or partly outside of laying areas, cleanliness. I think that for those parameters, the technology still needs to be developed, and it's mainly the image processing, and some of it can be done by accelerometry. We are working on it, but it's, well, still work in progress. For good health, lameness, integument alterations, coughing, milk somatic cell counts. Well, milk somatic cell counts to some extent are already available in sensor data, but the other ones, well, to my knowledge, there is not yet a good validated tool for automated lameness detection or scoring integument alterations and so on. But the possibilities are certainly available. For appropriate behavior, like agonistic behaviors or social interactions, particularly if we use the tracking devices, it should be possible to also automate these kinds of observations. But again, to my knowledge, it's not, at least not validated, so it needs some work done. There are also other traits of interest, and then it's more like the phenotypes, which are, for instance, of interest for economic reasons, such as resilience, locomotion, and feed intake. But of course, they are also linked to welfare. For instance, resilience. An animal with a better resilience will probably have less health problems, and therefore it can be beneficial for animal welfare. And there are some other things, such as eliminations, which we are using in our research, which can also be useful to automate. From a research point of view, we want to have flexible instruments which are tailored for our research questions, so not always the same, which are non-invasive and which are flexible. And well, for a research purpose, it's not a problem if a cow is wearing multiple sensors throughout an experiment. So, and that sort of things we are working on at the moment. For the free walk project, we've compared 3 housing types, 2 free walk barns and a cubicle barn as a reference. And there we particularly focused on recording and monitoring lying behavior, because the main difference between free walk barns and cubicle barns is the circumstances for the animals to lay down and get up and rest. Well, for that project, we collected data with pedometers, in our case, ice cubes. We also collected data with TrackLab software, but that we didn't exploit yet. We also applied accelerometers to the tail of the cows, and we made video footage, and that we did not do continuously, but we did during measurement weeks only, because it was too complex, too complicated to do that for a longer time. From ice cubes, we got this kind of data, and it looks, well, very dense in this graph. The ice cubes are giving us information on when our cow is laying down, and then, well, in the precision of date and hours, minutes and seconds, and the same for getting up, and the number of steps in 15 minutes. So quite a lot of information throughout time. If you're zooming in, then we have added also the data from that same cow with the accelerometer, and you see it seems to correspond, like the X, the Y, and the Z components of the accelerometer, but it's still much too dense to get really information out of it. But that's becoming different if we zoom into more detail. Here I have zoomed in to a very short time span of this data set. And well, this arrow shows, okay, when this black line is at a value of 1200, the animal is lying according to the ice cube. And you see, if you look at the other 3 lines, that there is a quite distinct pattern in the readings from the accelerometer between the lying bout and what's happening after. Here the cow is getting up, and then after that the pattern of the accelerometers is quite different. And then again the cow is going to lay down, and after that you see there is quite a distinct pattern in the readouts from the accelerometer. And that is because in the first case, the cow is, I don't know exactly, but either lying on the left flank and then in the next lying bout on the right flank, or the other way around. But you see a clear, distinct pattern between these 2 lying bouts. And then at the end of this laying bout, the cow gets up again. And then there's another phenomenon. You see a quite distinct pattern in the accelerometers. And what's happening there is that it's lifting up the tail and most likely either eliminating manure or urine. And well, in between these 2, the laying down and getting up, there's the lying bout. So what you can see here is that accelerometers can provide much more information than an ice cube currently does. An ice cube, in fact, also is an accelerometer. So it is useful, but it doesn't provide all the information that in principle is available. The existing algorithm that is used by ice robotics in the ice cube is very useful to find the times when animals get up and lay down, but it's not useful to inform us about how quick it's done, because it's presented as being something that's happening from a flip of a second, say then the animal's getting up or laying down, but actually it will take some time and not always the same amount of time. Another thing that we noticed when we are collecting data with ice cubes is that we get information that has multiple interpretations. For instance, an animal that's laying many hours a day, well, how do you relate that to welfare? Is it good? Is it bad? You can reason it both ways. The same is for short or long bout lengths. So, yeah, that's a drawback of this kind of information. You need more information to really be able to interpret it in terms of welfare. I think I better skip the feature extractions a little bit. Yeah, no, well, what we did is we also had video collected, and of course a video needs to be worked on. So we wanted to get out information out of the videos to score how quick an animal is laying down or getting up. So first we had to locate the animal, and that we did by, it was a barn with 4 cameras. So we looked at the four cameras at the times when we know that the animal is laying down, we locate the animal. And then when we have located it, we identify the animal by some markers, and then we can more easily follow in a video clip what is happening. And here it's another cow, but here is what we then did. We made some short videos that started 15 seconds before an animal was going to lay down according to the ice cubes, and it ended 15 seconds after it had completed the lying down according to the ice cube. And if we go through these videos in detail, we can quite accurately score the duration of this event by determining the starting and ending point of it. But that's very time consuming still. So we want to automate this kind of thing further. And therefore, yeah, we want to automate feature extraction. And I think that this trait, time needed to lay down or time needed to get up, is useful information, not only for, well, particularly for research purposes, but maybe also for herd management. But to be able to investigate that further, we need a lot of data to see what is the value of this trait. And well, therefore, I think we need validated tools to collect data first in a research setting, and then if it's useful for other purposes, for instance, for breeding or for herd management, then they may also be used in those settings. Well, another thing that I'm working on, and I'm now coming to an end, is the Gentle project, where we are using information from existing farmer sensors to predict resilience. Well, the first point of attention in this project is how to define resilience. We based it mainly on the ability to recalve. We used milk yield and other sensors, particularly body weight and activity and rumination, to predict resilience from first lactation sensor data. And for that, we obtained features from those sensor data. Well, sensor data is very dense data. So in order to have interpretable prediction models, it's quite common to extract features from those, such as well, variability of a curve or the slope of a curve, those kind of things. And then we apply different modeling approaches, regression techniques, but also machine learning. And we also tried to use raw sensor data as input for prediction models. And well, apparently that seems to also work and even provide useful information about, say, the difference in importance between early lactation sensor data and late lactation sensor data. And because resilience is also linked to welfare, this kind of work is also relevant for welfare, although resilience is currently not included in the definition or the assessment protocol of welfare quality. To conclude, now I come finally to the end, is that sensors are offering a great potential to assess welfare and also to phenotype animals, and that this can be useful for farm management applications and for research related to animal health and welfare. And that's also something I would like to stress, because, well, we are often asked to participate in experiments where, for instance, new types of housing are tested, and in our experimental farm, the main focus of those tests is usually whether these innovations help to reduce the gaseous emissions of the farm, the barns, but they also want to know whether, well, there are welfare consequences, and those are quite difficult to assess if you don't have good tools. And for that, I think better tools are really needed. And also, for instance, if people work on a new kind of flooring, they ask us, well, please have a look at whether the cows can walk on it. And well, also that is something, well, that is difficult to do in a research setting as on our farms without good tools. And I think that, well, those kind of tools that we do need to improve our research on animal welfare is still in its infancy in this big data era. So this is the last slide, and I would conclude. Well, if you have any questions, please let me know.
Thank you very much. We have one question in the chat. It's a quite general question, but as you has a background in breeding, probably you can answer properly. It's a question about Jarkko Ovels. How about epigenetics?
Well, I have a bit of trouble in answering the question because I don't exactly know what the question is. I mean,
it's quite general. I'm not an expert in this field, but I guess that he refers about the possible use of PLF sensors to track epigenetics.
Well, it could help. I think sensors could probably help to get better phenotypes of traits where epigenetics is involved. I don't know whether that answers the question, but
okay. If he can add more detail on the question, we can come back to it.
Okay.
There is another question from Angela Costa. Do you think sensors could help in reducing antimicrobial use in livestock?
Yes, to some extent, for sure. We aim to detect well, abnormalities in health in an early stage, and preferably even be able to prevent them from occurring. And well, this of course can contribute to a reduction of antibiotics usage. Yeah, that's for sure. If we go, for instance, can prevent cows from becoming lame, or well, if we have very early signals of other health problems, that for sure could contribute.
Okay, thank you. We are almost in time. We don't have more questions in the chat. So if every speaker wants to turn on their cameras in order to close the webinar, I think we have had a very interesting webinar and 3 excellent presentations about different topics related to PLF for welfare assessment and phenotyping. And all the presentations have some features in common. At the end, we have been talking about sensor development and the difficulties which can be different for different sensors and for different species. Then we need to go to sensor validation. That is quite difficult in some cases, as we have heard. And now, as expressed by Jarissa and by Anna and Jarkko, we are probably in some cases in the phase of sensor integration. We need to integrate data from different sensors and from different data sources to make decisions. And in my opinion, this is probably one of the most difficult parts of PLF, to make decisions on data, or for farmers to make decisions based on data. And we are painting a future where we could have animals with a lot of sensors measuring different things. And I think it's very interesting the view that Jarkko presented, that probably this is not what consumers or society is expecting from PLF. Probably we need to think on sensor that can be multi-purpose, to be used for different things, and to reduce the number of sensors, or to use less invasive sensors. So I would like to hear your opinion, not only Jarkko, but every speaker. How do you see this future with multiple sensors, with data privacy issues, data ownership issues? What do you think? Wait.
Well, I think what you mentioned, the invasiveness of the sensors, I think we are all aware of that it needs to be as non-invasive as possible, and we need to not harm the animals, of course, with our sensors. I don't think we do that, but it's important to bring the right message to the consumers, indeed, and to bring them. I like to compare it with, every consumer nowadays has a smartwatch, has a phone with a sensor that is monitoring. The new houses have also a fully equipped ventilation and domotics system. So it's actually the same thing, but then for pigs and cows and chickens.
I think it would also be beneficial if there are alternatives. Like a lot of information can be obtained by cameras, but you need very good image processing technology to retrieve information from images. But if that's possible, it's very tempting to apply it. But I think that in some cases, sensors may have advantages as well, particularly if cows, for instance, are going out of the barn or have a very well, a more complex living environment, which is difficult to track with cameras, then it's probably very difficult to use cameras. But if it's, for instance, sufficient to observe some aspects of the animals every day, only for half an hour or whatever, then cameras might be very, very useful. So yeah, I think there is also room for different solutions in different circumstances. And usually up to now, like dairy cows usually have some sensor, at least for identification carrying. And if you can put more sensors in there, you can already collect a lot of information without, I think, doing anything bad to the animal welfare.
From my side, I can add that more transparency is needed in the production of animals, and sensors can help us to deliver more information for consumers and maybe provide some intuitive labeling for the consumers to select the products which have a specific welfare attributes.
And what is also perhaps important is that the way how the data are used. So we use sensors to collect data from animals and their environment, but what we are actually using with that data, I mean, obviously, it is used to help the farmers to manage their farms better, and they need some tools and capacities for that. But then the messages that are sent to the consumers, they might be a little bit different, but it's still the same sensors and the same data could be used for those messages. So in that sense, thinking about how the data can be used, that is quite important. And then especially if we go to the really precise data that goes down to the farm level or even to animal level, then it is becoming more and more important that who actually owns the data, and for instance, how the data privacy is respected, so that for instance, farmers' privacy is protected, or maybe there are some people working on the farm who might also play a role in this context. So in that sense, it is not only about the business data, but also about the data of those people working with the animals or working in the food chain.
Okay, thank you very much to all of you. We are in time. We don't have, to my knowledge, new questions. So if you agree, we are finishing here. I want to thank you, all the attenders, and of course, all the presenters, and also the EAAP for supporting us in the organization of the webinar. Remember that you will have access to the video recording of the webinar in the EAAP website. Thank you again. That's all from my side. I don't know if any of you want to add something. If not, we finish here.
Thanks for sharing, Paco.
Thank you.
Thanks a lot.
Yeah, thanks for the opportunity to present.
Yeah, thanks for the organizers of the seminar.